Okay, good. My name is Daniël Caljouw. I'm a senior production engineer for Philips in Drachten, and I will present to you together with my colleague Haije Zijlstra the Z-BRE4K and Philips, the Z-BRE4K and Prophesy Philips use cases. To start, Z-BRE4K number of partners for 17 is 17. We have 3 different use cases as mentioned by Thanasis. Gestamp in automotive, SACMI CDS in packaging, and Philips in consumer electronics. The tools and deployed solutions are ontology, IDS, machine learning, and decision support system. For Prophesy, the number of partners was 14. Use cases in automotive, Jaguar Land Rover, and in consumer electronics, Philips. Tools and deployed solutions are cyber physical system, machine learning, and augmented reality. The use case intro, small intro on Philips Drachten, most well known for the shaver production. The plant started as a small shaver factory in 1950 and is now one of the largest innovation and production sites for Philips in Europe. We have approximately 2,000 employees of 35 nationalities. And on the left, we have the Z-BRE4K use case. I will bring it to you in more detail, but it's about a cutter on this line on the left, and the Prophesy use case is on the right. It's about cold forming of a cap. The Z-BRE4K use case, well, as said, is on a cutter. Is on the cold forming of the cutter in a flow line, where the first machine is a cold forming machine, and there are 11 machines in flow. So if the cold forming press stops, the whole line is shut down. On this press we have 6 dies, which have preventive and corrective maintenance, and the 2 common failures are punch breakage, which is on the right, and fatigue of the parts is on the left. And the punch breakage is on die 1, 3, and 6, and the fatigue is mainly on die 2. To make sure we all speak the same language, if we are talking about the data of the use case, EPFL mapped an ontology. On the right side you see the Philips use case with all the different classes and individuals in the ontology. If we are looking at the general architecture for Z-BRE4K, we have below the 3 use cases in the orange part. Above in blue we have the data transfer part, then the data analysis and the business logic levels. On the right side we have the Philips use case, this Philips specific use case architecture, where we have the collecting of the data at the machine. We have the transferring of the data to the IDS connector, where the IDS connector is also below, collecting the data from MQTT, transferring it into the right, data format, then storing it also in the Orion contact broker to make sure that the different consumers can fetch the data when needed. And we have some consumers in a containerized area in the Philips premises, and we have some consumers in the remote cloud. 3 of these consumers are data analysis parties. We have core innovation, which are fetching the data from the acoustic sensors in the press, do some anomaly detection and fault classification, and are running a remaining useful life estimation. Here you have the dashboard and the user interface of these, the anomaly detection below, where we see in red the normal value of this detection, and in black the line of the current signal. And on the right side we have the remaining useful life prediction, where we can predict in number of punches how many punches a die can do. We have as well the imec, or University in Ghent, with anomaly detection based on matrix profile. As you can see, the matrix profile looks towards the neighbors and detects a change in the profile or not. Some of the spikes, so the spikes are a sudden change, and the spikes are marked by colors, and you can see the signal in below. As you can see, there are some differences in the signals. If we have this matrix profile, we can cluster this data to find some common states and reoccurring states. And if we then have the data from maintenance or fault events, we can cluster them to these events and see if there is a common prediction to make. As you can see, the red crosses are the cutting faults. Then we have the smart maintenance platform by Atlantis Engineering. Well, I think Thanasis already mentioned a lot of this. We have a microservices-based architecture, which does the communication and is in the back end. We have a front end with different fault detection and different fault prediction. Fault detection rule-based, trend-based, and outlier detection-based, and fault prediction also in three ways. Within the smart maintenance platform, we see that this also really works. We have two fault detection approaches, the spikes and the trend-based, detecting the anomalies on the left. And on the right, we see that the smart maintenance platform at the first square at 7 o'clock detected a failure, where at the second square in purple we have a maintenance log. So, well, we didn't respond to it, to the anomaly, but it created a maintenance log, so we were there. On the right side, then we have the mobile notification, where we can send some feedback on the DSS. For now, the Z-BRE project, we still have 5 months till project end. We are evaluating machine learning results. We are about to implement the decision support systems. And we are collecting feedback from the end users on the shop floor and the maintenance guys and the different stakeholders. I think Haije is up to you now.
My name is Haije Zijlstra. I'm Senior Project Manager within the Global Manufacturing Engineering team within Philips. And I have been the project leader for Prophecy Work Package 7 for the past 3 years. Prophecy just finalized by the end of September, and Work Package 7 concerned the instantiation of the Prophecy PdM solutions at both the factories of Jaguar Land Rover as well as Philips. And as already said, in the next webinar in November, the Jaguar Land Rover use case will be presented. So, a bit on the background. When Philips was invited to join the Prophecy consortium, the target case to improve operational performance was defined around a cold forming production line where we produce high precision metal parts with high annual volumes, as you can see here on one production line, 15 million parts, and also related to that, a very high number of tools and specific wear parts. 600 maintenance work orders are triggered yearly. And the topic is here that of these 600 work orders, why is my screen not advancing here? 50% of these work orders, so it's a comparable number as Daniel presented, is triggered by either a breakdown or a quality issue. And as you can understand, our aim is to move away from preventive maintenance as well as from corrective maintenance in order to lower maintenance costs and get to that optimum point in the curve where we want to predict the health of our tools and perform the maintenance right on time. So this slide shows the fit between the prophecy vision and the future factory strategy of Philips. So that was for us also a second argument to join the Prophecy Consortium, where prophecy is about predictive maintenance, which is on our technology roadmap, as well as the use of digital tools in the area of maintenance, like augmented reality. And all these steps are considered as, let's say, building blocks, stepping stones towards predictive quality, which is of high importance to a mass production environment. So within the Prophecy project, both Jaguar Land Rover as well as Philips, more or less provided their production environment as a real live test area in which the prophecy technologies, as you can see a snapshot here, has been developed as well as integrated and tested and validated. So data from our existing IT systems has been fed to the, well, as we call it, the cyber physical system of the prophecy platform. But also data from Jaguar Land Rover has been collected and processed in the prophecy platform, and as well as presenting it on different kind of dashboards using the outcome of the algorithms in visualizations. For instance, in the AR viewer, we were also able to feed back the outcomes of the PdM data analytics to the factories of Jaguar Land Rover and Philips. And then this generic architecture, it's good to know this is based on the Mantis reference architecture, and an important thing is that existing legacy manufacturing IT systems from our both our plants can be connected to this state-of-the-art cloud-based PdM platform, which is, I would say, a prerequisite for further, let's say, expansion and for new prospects for this technology. So then, an overview of the use cases we defined within Prophecy in the Philips demonstrator. We have defined two use cases around the prediction of the remaining useful lifetime, we call RUL, tooling wear parts. We had two different processes in our cold forming line, which is the cold forming process, and which is the, let's say, the blanking process, cutting out of the end product. So we have two different processes. We have two different data streams being fed to the predictive maintenance platform Prophesy. And the data from these use cases 1 and 2, the remaining useful life calculation from the platform, is reused amongst others in the use case number 3, which was devoted to produce real-time information to the maintenance technicians by offering them a digital tool, for instance, a tablet, providing information of the tool at hand. So actual information on a wear part showing the number of strokes that can be still can be produced with this tool, either, let's say, a red indicator for a wear part that is already worn out and should be replaced, or should be grinded to have another, let's say, production run capacity available. So, as time is limited, I will try to provide you an overview of the Prophesy project in one slide. But I'm cheating a little bit, so I have a lot of pictures here. So we started the project collecting user stories from our end users and stakeholders. And we asked them, what do you expect from these novel technologies, these predictive maintenance technologies that can be developed in this project? And then we defined these 3 use cases as indicated in the previous slide. Also and specifically addressing a subset of the input that has been received from the user stories. And you can imagine that we have shared gigabytes of manufacturing data with the Prophesy technology partners. Therefore, a secure data sharing model has been developed to get the data from Philips to the partners, and also to receive actual feedback to the production area, where in our case, we must say we always have chosen to have a human in the loop, as these production processes are very, let's say, sensitive to damage in case of any kind of, let's say, strange behavior from the algorithm. And the next step was the integration of wireless sensors in the blanking machine, and that delivered really useful insights to the process engineer. We could actually see with, let's say, very easy installable sensors the differences between 2 tools on the machine. So even when a tool change was not registered by the operator, we could see from the data. We've been installing brand count measurement systems on the existing production equipment, enabling data collection of real process data. So we have been actually measuring, we say, process forces, and you can see a little bit more here. We have integrated sensors very close to where the actual cutting operation and forming operation takes place in the production tooling. And I think you can imagine that this needed quite some signatures before we were actually allowed to cut the steel here. But doing so, we were able to get real clean data from the process. Not to forget the AR viewer, as already also indicated in the previous slide. The AR viewer has been developed in close collaboration with the end users, and this has led to, let's say, a very comprehensive and a very easy to use tool, where your tool can be configured in an online configurator, and you can connect all your data to the specific tool, which can easily be, let's say, visualized for the tool mechanic. And also connect live data streams to this particular asset. And a live data stream, for instance, can be a output of a machine learning algorithm predicting the remaining useful life. Last but not least, extensive data pre-processing, data analysis has been performed on these process data. And in the recent weeks, I must say, we derived results from the data analytics that the algorithms were able to identify trends in the data, which actually these production runs ended in a tool failure. And these two examples just show that here at the vertical line, the production was stopped by the operator, and the algorithm already indicated, let's say, strange behavior, deviating behavior, hours before the actual problem occurred. So we say, yes, this is a very promising technology. So in the final month of the project, so last month, we have presented the results to the end users and stakeholders. It was a group of about 20 people from the shop floor, from engineering departments, IT department, and management. And we have asked them a lot of questions. I will just show you a few here. The respondents, to our opinion, show a very high level of confidence in both the technical outcomes as well as the financial benefits of implementation of PdM technologies. But also, if management indicates, like here, that they are willing to invest in PdM technology even with a payback period of 3 years, I think we must conclude that this technology actually does contribute to the long-term strategy, at least of our company. Last but not least, this kind of verbatim comments are really, really positive and show once more high confidence that people have in these novel technologies using computerized systems in their daily work. On the financial end, stay tuned for the third webinar in November. There are also ROI and cost-benefit calculations for PdM implementation will be addressed in that webinar. This brings me to my final slide. I would say the Prophecy project, have once more proven that great benefits can be achieved by the implementation of state-of-the-art PdM solutions. And I am really convinced that this potential can be fully utilized if specialists from different domains work in close collaboration, like data scientists, process specialists, measurement specialists, and certainly the end users. And here I'm fully with Dr. Naskos that data collection does not start with tools, with digital tools, or with data collection systems. It starts with understanding the process, which is really the first step. And yes, it has been a struggle for us to perform the implementation and testing in real life production lines, but this is just necessary to validate this technology in real life environment. Main outcomes are the positive results of data analysis by machine learning. As I explained, the technology really outperforms existing computerized control systems or even the human-in-the-loop systems to be hours before existing systems would be able to detect an issue. Also, the AR technology is well received by the end users, and certainly related to the fact that we have, let's say, involved them pretty much in the development of this digital tool. Next steps for Prophecy will be, let's say, the final presentation in November. We will be closing our project administrations very soon. But in the meantime, we are investigating some extended collaboration on the machine learning part, where we can say from a project management and deliverable point of view, we did the whole thing from A to Z. But we really would like to improve, let's say, the knowledge of the process, improve the data analytics models, and therefore improve, let's say, the chance of expansion of these technologies in our factory. And in the same time, preparations for the implementation of AR tools in our maintenance workshops are already in progress. So I think these are very, let's say, positive outcomes. So here, both the data analytics and the academic data scientist partners we are contacting here, how to continue this work. So this takes me to the end of my presentation. Thank you very much. And for now, back to you, Diego, I would say.